Second video that I'm going to do on correlation and the line of best fit. And so the very first video we talked about getting the line of best fit, and now that you've known how to do that, let's say we had a line of best fit, and I'm going to go back to my ice cream and temperature example. So as we said, that this was a positive correlation, and that the temperature, as the temperature increases, the number of ice cream sold at a particular store increases. And what we can do now is, now that we have a line of best fit, and I'm going to tell you that it's going to be, my slope is 0.64, approximately 0.64, and my y-intercept is negative 32.5, and if you take a look, it goes way down there. We can now use this information to write the equation of a line in slope-intercept form, y equals mx plus b, and predict what should happen. Now, it's not guaranteed to happen, but it's used to predict what's going to happen. So once again, I'm going to write the equation of a line, and it should be something like y equals, maybe I'll do 0.65 x minus 32. And I'm rounding, apparently inappropriately, but I am rounding. And so I'm going to go over to here, and I'm going to say, all right, well, if I'm the owner of the ice cream shop, I know that my equation is y equals 0.65 x being the temperature, minus 32. I can use this information, and let's say I knew in the weekend it's going to be, the temperature is going to be 70 degrees, 96 degrees on Saturday, and 100 degrees on Sunday. Let's see how many ice creams I should expect to sell. Now,
no, didn't work anyway, Phoebe.
What you're going to do is you're going to take
did you get
y equals 0.65 times 70 minus 32, and as good as I am, I'm not going to try doing that in my head. So let's see. I'm going to pull up my calculator. Hopefully. Oh, here we go. And I said 0.65 times 70 minus 32. And that tells me that I'm going to sell approximately 13 and a half ice creams. Well, obviously I can't sell half an ice cream, so I will round that up. I will round that up to 14 ice creams. I can expect to sell 14 ice creams on Saturday. No, I'm sorry, on Friday. On Saturday, I'm selling it's going to be 96 degrees.
This is how you write Eden.
So once again, let's see. I'm going to say 0.65 times 90. Oops.
So can you write? Oh, you're going to decorate.
Times 90 minus 32. And it looks like on Saturday, I can expect to sell about 26 and a half, but once again, I can't sell 26 and a half. Oh, wait. It was 96 degrees, so I have a mistake here. That's fine. So all I'm going to do is I'm just going to go up to here. I'm going to change this into 96. So if it's 96 degrees, it's 30.4. So once again, even though you would normally round down, I can't sell 4/10 of an ice cream. So I'm going to round up to 31 ice creams. And I'm going to say, on Saturday, I can expect to sell about 31 ice creams. And then Sunday is supposed to be 100 degrees. So Sunday is going to be, sounds pretty good for business. Let's see, 0.65 times 100. Well, that's going to be 65 minus 32, which should be about 33. Not about, should be 33. And sure enough, with 100 degrees, I should expect to sell 33 ice creams, which is pretty fantastic, being in the ice cream business. So when it's 70, it should be 14. When it's 96, 31. And when it's 100, it should be 33. And if I were to put those values in,
How did you mess up?
oh my goodness, I've already forgotten what those values were.
Is that the D for Eden?
70 was 14.
What we could do is let's use a different colour so it's a little bit.
Take a look. My 100 was 33. And then 96 was what? Oops. 96 was 31.
I'll just leave it, that's fine. Now can you do an E next to it?
You can see it didn't really change my graph at all. Everything seems to be pretty much the same. So that's it. So like I said, you can use this as a predictor, which is always useful. Now, there is one other thing I want to take a quick look at. Oh, no, wrong graph. And that's, can we use the graph to predict what would happen on my y value? So this was when I had absences and my grades. So you can see as students were absent, the number of absences increases, their grades decrease. And I actually had changed this data to 11. Oh wait, no. I'm sorry. Yes.
All done?
To like this. So 1161. So my line of best bet is negative 2.99, which I'm going to round to -3. And my y-intercept is 95. So,
because it has to fit in here. We can't put that in there.
what happens, let's say,
On here too.
I'm going to say y equals -3x plus 95. Let's say, just to test this, I had a 65, and I want to see, if I had a 65%, I want to know how many days should I have expected to be absent. Well, that's my y value, and it's equal to -3x plus 95. I'm going to isolate my x, so I'm going to subtract 95 from both sides. And that gives me a -30 equals a -3x. I'm going to divide both sides by -3, and x equals 10. So,
could you write her name
if you weren't sure, you could always guess and check.
Not this pen.
And just plug in a bunch of x values until you get that. So on this occasion, it looks like if I was absent 10 times, I should expect to get a 65.
Like this, remember?
Now, if you take a look, that's actually one of my values. And so that certainly makes sense. Once again, it's a predictor, and it doesn't mean if you were absent 10 times, you were definitely going to get a 65. It's just saying if you're absent 10 times, your grade it's going to be lower, and that does make sense because you're not there to receive the material.
Oh, great.
But anyway, that's it. That's how you use the line of best fit to make predictions. It's not to predict the future exactly, but it's just to make predictions. Anomalies do happen. All right, I hope this helps. Enjoy.